All right, number 15, this one wants us to find the second derivative. Okay, if you look at that notation, it says find d squared y over dx squared. So this is the notation for the second derivative. So since it wants the second derivative, I'm going to use the standard dy dx form just so you can kind of see the whole process. So e to the 3y plus x equals 2y. And I don't think it'll be that bad with this problem. Okay. So we're doing the derivative with respect to x. So when we do the derivative of e to the x or e to the whatever, we get the same thing. But since we're doing, we have something other than just a single variable, we're going to have to do the derivative of the numerator or the power, kind of like the chain rule. And so derivative of e to the 3y is still e to the 3y. And then you have to multiply times the derivative of here. So derivative of 3y would just be 3. And then derivative of y with respect to x is going to be dy dx. Derivative of x would just be 1. And then over here, derivative of 2y. So derivative of 2y would just be 2. Derivative of y is going to give us dy dx. All right. I'm going to simplify and move the dy dx terms to the same side so we can factor it out. So this is going to be 3e to the 3y dy dx. Okay, so let's multiply all that together. I'm going to subtract and move this over, so it's going to be a minus 2 dy dx, and then I'm going to move that 1 back over. So I'm going to subtract 1, so it's by itself over there, so minus 1. The two dy dx terms are together. I'm going to factor dy dx out. And then in parentheses, we'll be left with 3e to the 3y minus 2 equal negative 1. And then we'll divide by this. I don't know why I put equal. This is times. Okay, just factoring it out. We'll divide by this, and that'll give me dy dx. So my first derivative negative 1 over and so once we find our first derivative, we're now going to find the second derivative. I'm going to start on this side, working from here. So I'm going to find the derivative of this function. So I have a negative 1 over 3e to the 3y minus 2. A couple things you can do. You can do the quotient rule. You can move this up as a negative exponent and do the product rule. I like doing the product rule, but just for simplicity, since it's in the quotient form, we'll do quotient rule. So quotient rule is low, and I say d high minus high d low all over low squared, or the bottom squared. So the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And so that will be equal to low, which is this part, 3e 3y minus 2, that's low. Derivative of the top is a constant, so it's going to be times 0. So this whole term is going to zero out. Low d high minus high, so this is -1, minus high d low, the derivative of the bottom. So we're going to do derivative of 3e to the 3y. So the constant will come out. Derivative of e to the x or e to the power is going to be the same. So it's going to be e 3y times the derivative of 3y. That's going to give us a times 3. And derivative with respect to y is going to be dy dx. So low d high minus high d low. Derivative of 2 is 0, so I just didn't add that part. D low all over low squared. All right, I'm going to clean this up. We're going to have to use dy dx, which is what we just got here, and multiply that up here to simplify everything. So that part zeroes out. So to clean this up a little bit, negative times a negative is a positive. 3 times 3 is 9, so I'm going to have a 9e to the 3y. So that's 3 times 3 is 9, e to the 3y. Negative, negative is positive. All right, now the dy dx, so this is going to be times a negative 1 over 3e to the 3y minus 2 all over the bottom squared, 3e to the 3y minus 2 quantity squared. Now we could probably do some manipulation, clean up a little bit, but just for the sake of time, we're going to leave it like here, and we'll go on. So